Welcome to the second lesson of our trigonometry unit. Today we're going to briefly look at something called the secondary or reciprocal trig ratios. They are secondary because they're not necessarily trig ratios that we have to be able to use, but they're related to the first three, or what we call the primary trig ratios, which are the SOHCAHTOA ratios that we know already. For those of you going on to advanced functions or onto a college program, you may encounter these. Advanced functions, you'll definitely encounter them, but in college you may encounter these secondary trig ratios, and students sometimes come back and say, you know, this would be one thing that I wish we would learn, and it technically isn't part of this course, but it can be an important thing for some of you depending on which pathway you are taking here. All right, so our goal with this mini lesson is that you can relate secondary trig ratios to the corresponding primary ratio and then use the primary ratio to determine an unknown value. All right, so our primary trig ratios that we should know are the ones dealing with SOHCAHTOA. It's the sine, cosine, and tangent. So what I have here are just some blanks to fill in. So the sine of angle C we know is opposite divided by hypotenuse. The cosine of angle C is adjacent divided by hypotenuse, and the tan of angle C would be opposite divided by adjacent. So I'm just going to jot those in here. Okay, so we have those written in here. Our secondary trig ratios are also known as the reciprocal trig ratios. And reciprocal, when you think of dividing fractions, we used to say multiply by the reciprocal, and reciprocal just means flip it over. Or we said that lines that are perpendicular had slopes that were negative reciprocals of each other, and we flipped the fraction over. Well, that's exactly what we're doing here. Our secondary trig ratios are just the reciprocal of the primary trig ratios. So if the sine of angle C is opposite over hypotenuse, the cosecant of angle C, cosecant is the reciprocal of our sine function. So the sine function, its reciprocal is cosecant, and when we write that, we will have hypotenuse over opposite. And then our cosine function, its reciprocal, if I flip it over and get hypotenuse over adjacent, that's called the secant of angle C. The tangent, if I flip it over, it's called the cotangent. And so it's adjacent over opposite. So I'll just jot those in there as well. Okay, so the cosecant of angle C is hypotenuse over opposite, the secant of angle C is hypotenuse over adjacent, and the cotangent of angle C is adjacent over opposite. So it's just the reciprocal. Similarly, we could also write them as the reciprocal, let me get the pencil tool here, the reciprocal of of sine C. So it's going to be 1 divided by the sine of angle C. The secant is really the reciprocal of the cosine function, so it's 1 divided by the cosine of angle C. The cotangent is the reciprocal of the tangent, so cotangent of C is 1 divided by the tan, or tangent of angle C. All right, so how does this come into play here? So we're going to work with this. Determine the exact primary and secondary trig ratios for triangle ABC relative to angle A. So I'm going to mark angle here, angle A here, and label my sides as hypotenuse. So side B, little b should be hypotenuse. Little side A is 5 units, and it is our opposite to our angle of reference A, and that leaves us side of 10 to be the adjacent side, and it's little side C. Okay, so we know side A, which is 5, we know side C is 10. I need to get side B before I can state the sine of angle A, which will be 5 over whatever B is equal to. So when I know two sides of a right triangle, I can find the third using the Pythagorean theorem, and it is the hypotenuse that I need to find. So I'm going to take my other two sides squared, added together. All right, so 5 squared is 25, 10 squared is 100. So that's going to give us b squared being 125. B then, since it's a length, it's just the positive square root of 125, which we know from our radical rules earlier, 125 could be written as 25 times multiplied by 5. So that dot just means to multiply. I'm going to square root the 25 and make that 5, and then times the square root of 5. So it was just the 25 that I took the square root of, and it became the 5 when I took it out. Okay, so that is my exact value. So notice I used the word exact here. my exact value for B is that it is 5 times the square root of 5 units long. All right, so if I state my primary trig ratios, I know that the sine of angle A would be opposite over hypotenuse, and opposite is 5. Hypotenuse is 5 times the square root of 5. And then I can actually reduce this. 5 and 5 reduce, and leaves you with 1 over the square root of 5. Okay, so the sine of angle A is 1 over the square root of 5 as an exact value here. The cosine of angle A is adjacent divided by hypotenuse, so that's going to be 10 for my adjacent side. Hypotenuse was 5 root 5. Again, the 5 and the 10 can reduce. 5 goes into itself once and into 10 twice. So that's going to leave us with 2 over the square root of 5. And then the last one, if I can slide that in here, the tan of angle A is going to equal, I'm just going to move A and opposite out of the way here. I'll just write that inside here, A and op. There we go. Tan of angle A would be opposite over, so that's 5, adjacent, 10, which is equivalent to 1/2 in lowest terms. All right, now, when I want to state my secondary trig ratios, all I have to do is take the primary, the corresponding primary one, and flip it over. So the sine of angle A was 1 over root 5. The cosecant is the reciprocal of the sine of angle A, which makes that root 5 over 1, which really is just the square root of 5. Cosine goes with the secant of A. It's just going to be the reciprocal. So that becomes root 5 over 2, which can't be put in lower terms. And then cotangent of angle A is going to be the reciprocal of the tan, which is going to become 2 over 1, which is just plain old 2. And that's all there is to in terms of our secondary trig ratios. Now we need to make sure we know how to use our calculator. Now our calculators don't have a cosecant, secant, or cotangent button, so we always have to just change them back in terms of sine, cos, and tan. The only reason we use the cosecant, secant, and cotangent is so that we don't have to work with fractions necessarily. So let's move to the next page actually here. I think I've got it on the next slide. Yeah. All right, so use your calculator. Now, the first three you should be able to do knowing what you know already from the last few years. The sine of 30 degrees, you punch that into your calculator, you're going to end up with that equaling 0.5. I don't even need to take that to 4 decimal places. If I wanted 4 decimal places, I would just fill in the rest with zeros. All right, and then the cosecant of 65 degrees, well, that doesn't work out to be a terminating decimal like the previous one. That's going to be approximately equal to 0.4226 when we put that in the calculator. And the tangent of 75 degrees, again, not an exact value. We're going to have to round that. I got 3.7321 for that value. Now, if I want the cosecant of 30 degrees, all I need to do is rewrite that as the reciprocal of its matching trig ratio. So cosecant goes with sine, and how I remember that is the S always goes with the C. Okay, so sine goes with cosecant. The cosecant of 30 degrees will be the reciprocal of the sine of 30 degrees. So on my calculator, I'm going to hit 1 divided by, and then I put in 30 and hit sine and equals. Some of you will just do 1 divided by sine, 30, hit equals, and that will work for you. If you do that, you should end up with a 2 out of that, which should make sense because 0.5 really is a half. If I take that and flip it over, I get a 2 over 1, which is really just 2, but your calculator should spit out 2 as an answer when you do that calculation. The secant of 65 degrees, again, we could do 1 over, secant matches with cos, so this starts with C, goes with the one that starts with an S. That's going to match up with the 1 divided by the cosine of 65 degrees. Put that into your calculator. You should get about 2.3662. 2.3662 approximately there. Okay, and the last one, this is going to equal 1 divided by the tangent of 75 degrees, and that I got approximately equal to 0.2679. And hopefully I haven't made any mistakes with those, but of course double check my work, make sure that you agree and know how to use your calculator. All right, next example, now we're going to solve for the angle knowing what the trig ratio is actually equal to. We know that to find theta, we really do the inverse function of sine on that value of 0.5294. And that second function key, I said to the nearest degree here, I think it's approximately 32 degrees for that one. Okay, likewise, you should be able to solve for the other two, the cosine and the tan. If you do, you should get approximately 115 degrees for part B and for part C. Again, put that in your calculator. I would do 2 divided by 7, get that answer, and then second function tan. That gave me approximately 16 degrees here. Okay, now part D gets into the cosecant. Now I said that these are just the reciprocal. The cosecant would match up with sine, because C matches with the S. If I flip the left side over, cosecant theta over 1, if I flip that over, I'm going to get 1 over sine theta. 1 over cosecant theta, which is equivalent to sine theta. That then means on the other side, I also have to flip that over, and it's going to give us 1 divided by 4.9952. So then I can do my second function sine on the 1 divided by 4.9952. Okay, so I'm really doing this on the fraction that we have there. So I'm flipping it over to take the reciprocal. I'm taking the reciprocal of both sides, and that will give me theta being approximately equal to 12 degrees, I believe, here. Okay, so try that with the other ones. Actually, I'll walk you through this one because it's a fraction. If I take the secant, if I flip it over, it's going to match up with the cos, but I have to also take the reciprocal of the other side. So I'm taking really the reciprocal of both sides here. And then I would have my theta being the inverse function of cos on that 7 over 11. I'm just running out of room here. My theta then is approximately equal to 50 degrees. And similarly, the cotangent of theta, its reciprocal is tan theta, and then I'm doing the reciprocal of the other side as well. Okay, so theta will approximately be equal to 20 degrees on that one. Okay, so hopefully that makes sense. Again, this is something you will need if you do advanced functions, or sometimes in college people will need to understand what secondary trig ratios are.